Hello, my name is Kyle Demanis, and I'll be talking about the piano physics lecture by Nick Giordano held near the beginning of the semester. So one of the main reasons that I chose this lecture to go ahead and present a video on is because I myself play piano. I've been playing for the past 14 years, and so I was really interested to hear more about the physics behind it, because I've always understood the sound and the feelings that you're supposed to get as you perform, but I've never understood all the physics concepts behind it. So I found that this lecture would be very helpful to me, and I'd be able to maybe apply it to the future. So to talk a little bit about the history of the piano, the first piano was first owned by Bartolomeo Cristofori in Florence in 1720, and something that's a little bit different about his piano than all the ones of today's society is that now they typically have 88 keys, whereas his had 49, and also the sound was very different. So for his piano, you didn't really have the soft versus loud sound. You had just one tone, and no matter how hard you hit the keys, it wouldn't give you any different tone. So to explain why today's pianos have this difference in loudness and softness, you have a hammer, and so when you hit the keys, the hammer hits the string and thus producing a different sound. But actually there's this thing called escapement, which right before the hammer hits the string, it is actually released from the keys. So it has this little bit of air right before it hits the string. So something that's also important is what the hammer is actually made of. So in the past, you would have your wooden hammer, but then around it would be a leather covering. But currently, in these days, we use a felt covering instead. It does basically the same thing, except felt tends to last for longer periods of time, so that's just durability. So what's important about this covering, though, is that as the hammer hits the string, as this covering hits the string, it compresses. And as it compresses, it acts almost like a linear string, or you would imagine it that way. But actually, in reality, it's nonlinear. So it's like the higher compressions, the stiffer it is, and so the louder it is. So this gives it change in tone and voice. But also due to this non-linearity, it also gives this sense of tone color. So it's not just you can hear if it's loud versus soft, but you can hear a change in the tone color of the piano you're playing. So that's why sometimes if you're in the car and you're listening to a stereo, like a piano song, you'll hear differences, even though the volume is not changing. You'll be able to hear when the soft parts are coming, when the loud parts are coming, all due to this change in tone color. So now that we've talked about the loudness and the softness, let's talk a little bit about how the sound is actually created. So as the hammer hits a string, you hear different tones. So this is mainly because of the strings themselves. So actually the length of the string is very important as to the tone of that you hear. So the longer it is, generally, the deeper it is. So usually if you double the string length, you reduce it by an octave. But unfortunately you can't, it becomes hard for like when you have a 7-octave piano to do this. So what they've actually done is they can either make the strings heavier or thicker in order to increase the sound, or you use a steel core with a copper wiring, which adds mass, which thus you can make to make your bass strings and thus have lower sounds. Something about these strings that actually surprised me, though, that I wasn't aware of is because I always thought that 7 octaves was a very decent number, so I never really thought about why they stopped there. But there's actually a very good reason, is that if you can't go above that or below that due to the different frequencies that you would hear as a person. So if it's too low, you would actually end up hearing a click instead of a musical tone. And if it's too high, it'd be the same. So actually humans can only hear between 25 hertz and 5,000 hertz, so that's about 7 octaves. So also to talk about a little bit how the sound is generated, there's something called a soundboard, which is the spruce wood at the end of a piano, and what it does is it takes the vibrations of the strings and pretty much amplifies it like a speaker. So, some problems though that you can't actually hear bass frequency bass notes is because usually the soundboard is either too small or there's something called a fundamental partial that's missing from the bass. So the reason it sounds like this fundamental partial is missing is just due to the placement of the hammer on the strings themselves. But because this partial is missing, you can actually hear more harmonious notes between all the other notes, so it is essential. So to go and summarize, the piano itself is a very difficult instrument to completely understand. It's very complicated, and a lot of it is based on our own perceptions and our ideals, but the tones and all the sounds behind it are very structured, and they have a very precise way that they're done, and it's very difficult to control that. But I mean, you can still enjoy piano and all that it is, and I'm really glad that I got to learn at least more of the physics behind it, so when I play, I still have an idea of what's going on, a little bit more than me just banging on keys.